Alright, this is the video for lesson 11.3. We start off with the warm-up here, so if you want to pause the video and try that. So first of all, just using your general rules of PEMDAS, do your exponents first, and then you can do your multiplication, and then you can distribute. This one you can just go ahead and multiply straight out, and then we're trying to collect our terms together, so we have the squared terms first, then we have the non-squared terms, and then we can just combine these two terms. So if we bring 4 to this side, it becomes -4, so those would cancel, leaving us just 18. And the general form is, of course, the one that equals 0. This one where we complete the square, so you bring your x terms together and your y terms together, bring the number to the other side. Half the coefficient of 8 is 4. 4 squared is 16, and I want 16, I want 0, so subtract 16. Half of -6 is -3. -3 squared is 9, and I want 9, I want 0, so subtract 9. And then we can start bringing terms to the other side. So add 16, add 9, and then we get 36. So this is r squared, so that gives us radius of 6, and the centre would just be the opposite for both of those two terms. I'm not sure these are exactly the same questions, but just so we can see a few. So from question 4, we're given this equation, and we have to find the normal. So differentiate, bring the power to the front, decrease the power by 1. Bring the power to the front, decrease the power by 1. But as it's y, make sure we put dy by dx. And then we solve for dy by dx. When it's negative, I tend to bring it to the side to make it positive. I think that makes this a little easier. Divide both sides by 6y, and you could divide by 2 as well to simplify. And then you can substitute in. We know x is 3, so that gives us 12. And we know y is -2, so we know that gives us -6. And we have a slope, therefore, of -2. Now, as this says normal, though, I need to do the negative reciprocal, so that will be 1/2. And then I can use the point slope formula with the point given at the top, and we can distribute this out. I multiply both sides by 2. I always think that looks a little bit better. And actually for this one, I could solve for y, but actually I chose to solve for x, mainly for the second part of the question. The question says, when does the normal then intersect again with this equation here? So this is kind of similar to what we did in Unit 10. This is just going to be a substitution problem. As I know what x equals, I can substitute in for x up here, giving me an equation with just one variable instead of 2 variables. So if I go ahead and substitute in here, so wherever it says x, I'm going to put 2y plus 7. I can distribute, I can multiply out the set of parentheses. I can then distribute the 4 through. I can then start collecting terms. The thing that makes this slightly easier is I do know that 2 is one of the values for this one. Actually, no, I'm not sure. No, I'm thinking of a different question. As we come into factor this one, not the easiest one to factor, I would agree. You might just choose quadratic formula with that just being such big numbers. This turns out to be the answer. So one of the answers is +2, and the other answer is negative 86. And this was the first part from 5. Remember for y-intercepts, you set x equal to 0 and solve. For x-intercepts, you set y equal to 0 and solve. I actually drew the graph for this one just so I could actually figure out exactly what the range was and the domain. And to check for even and odd functions about which axis, we can replace x with -x. And if we end up with the same thing, that it's even, so we know that one's symmetric. And also the same for y as well, replaced by -y, just like we did last lesson. And you can always go refer back to that one if necessary. Question 7 is particularly difficult, so I'm just going to scroll through some of the answers so you can take a look. There we can see A and B. Obviously pause the video if need be. There's C. And if I remember correctly, D is particularly difficult. And I think that's as far as E goes. Oh, a little bit further for E. Whoops. Let me just reveal that very last part there as well. That part might not be obvious at all. Alright, getting on to the main part of today's lesson. So this is the implicit differentiation part 2. So this is what we're trying to differentiate. I put the clue here at the top, use the product rule. Notice that x and y are multiplied together here. So we're going back to that earlier unit. Set up for u and v. Differentiate both independently. Bring the power to the front, decrease the power by 1. As it's a y, put dy by dx in. And then we can use our formula for the product rule here. Substitute in. And that's it. All we have to do is differentiate this one. No, find the slope or anything. So we're finished at this point. Notice technically there's no equal sign on this because it's just an expression. So this would what we get when we actually differentiate that. Going on to a slightly longer problem. This is probably a slightly more typical question. The perils of working from home. So this is my U term, this is my V term. I'm not too worried about the 48 part right now. I just need to differentiate this. I know the differential of 48 is 0, but to differentiate this, I need the product rule. So differentiate this one, differentiate this one, and then I can use that formula. I can use the U dV. So when I multiply these two together, I would get this, plus V du, that would be these two multiplied together, equals the differential of 48, which is 0. Then from here, I want to solve for dy by dx. So bring this term to the side, make it negative, and then instead of timesing by 6x to the 4, I can divide by 6x to the 4. If we simplify, it just makes it a little bit easier to substitute, and then we just plugged in our values for x and y, and a value of 8, and that's it actually. You could easily be asked to write the equation of the tangent or the normal now, like you did in the last section, but for right now, that would actually work for that question. Now, there is an alternative method for this question, although I think that one's pretty good actually. Just to make you aware, obviously with an equation, as long as you do the same thing to both sides, I could take the ln of both sides on this question, and then using my rules of logs, I could say it's the ln of the first one, plus the ln of the second one, plus the ln of the third one, and then equals ln of 48. Remember, ln of 48 is just going to be a number, so when I differentiate that, it's going to be 0 in a second. Also, using the rules of logs, I can bring exponents to the front, and then differential of a number is 0. Differential of ln of x is just 1 over x. Differential of ln of y is 1 over y, but as it's a y, I need to put dy by dx. And once again, ln of 48 is a number, so when I differentiate it, I get 0. Bring the positive 4 over x to the side, and then instead of timesing by 2 over y, I can divide by 2 over y. And this should be much easier to simplify. Remember when we got fraction divided by fraction, you're going to times by the reciprocal. And then when we simplify this, you would just get negative 2y over x. That is the same thing that we found over here, but notice on this question, I didn't actually need to use the product rule. So sometimes it's very useful to notice properties of ln functions. They can sometimes make questions just a little bit easier to answer. That does it for lesson 11.3. Go try the questions from the exercise and keep practicing.